All right, let me clear the page and get started on a second type of intermolecular force. We can go a little quicker on this one because it uses a lot of what we just talked about. In some molecules that have a dipole force that we just talked about, some molecules that have this dipole force, like for example HF, this is another example of a molecule that is polar, so there is a partial positive on one end, a partial negative on the other end because of the dipole moment. In a sample of HF in a container, I'll have lots of these molecules floating around, bopping around. We will see this force of attraction between the partial positive of one side of one molecule and the partial negative of a second molecule, just like we saw with the HCl. So we'll see intermolecular forces, these forces of attractions between the two different molecules. Now it turns out in HF, as opposed to HCl, this intermolecular force is much stronger than it was in HCl. This particular intermolecular force is so much stronger than the dipole force we saw in HCl that we've given it a separate name. This second type of intermolecular force is called hydrogen bonding. Now let me caution you, it is not a bond. It is an intermolecular force, and we've already talked about the difference between an intermolecular force and an intramolecular force. But the name of this type of force is indeed hydrogen bonding, or sometimes we'll just say it's an H bond, but it's not a bond. Must be a biologist that named it or something like that. It is a type of intermolecular force. It is stronger than a dipole force, but it is similar enough to a dipole force that we call it a special case of dipole force. This is actually a special case of a dipole force. A special case that is stronger. And it occurs, we see it in samples where we have a hydrogen bonded to a fluorine, or a hydrogen bonded to a nitrogen, or a hydrogen bonded to an oxygen. If you have a molecule with a hydrogen bonded to fluorine, or a hydrogen bonded to nitrogen, or a hydrogen bonded to oxygen, we see this special intermolecular force, this special case of dipole force. We see hydrogen bonding. It's a particularly strong dipole force. In HN, this occurs in molecules like ammonia. The molecule of ammonia looks like this in its Lewis structure. Remember that when we draw the Lewis structure, we draw it flat, but this is actually a trigonal, pyramidal, or pyramidal molecule. In 3 dimensions, it looks something like this. It's a little pyramid with the lone pair on one side. We have a dipole moment in this molecule. The nitrogen's partial negative, the hydrogens are partial positive. And so a second molecule of ammonia can be attracted to the first molecule of ammonia in an attraction between the partial positive of the hydrogen on the one molecule of ammonia and the partial negative on a nitrogen of a second molecule of ammonia. Notice that this is not the hydrogen bond. This bond between nitrogen and hydrogen is actually the bond, the intramolecular force between the nitrogen and hydrogen. It's a legitimate bond. This dashed line between two different molecules is our intermolecular force called hydrogen bonding. So hydrogen bonding is a type of intermolecular force. It's a special type of dipole force, or a special case of a dipole force, and it is stronger than an ordinary dipole force, but it's an attraction between those two molecules.